We have already seen now how to add irrational numbers, how to subtract two irrational numbers, also how to multiply. Now we will see how we divide two irrational numbers. Just take this example, any irrational number, let us take root 24. This is irrational, is not it? Root 25 is rational. Why? If I write root 25, the answer is plus or minus 5. This is a rational number. So, root 25 is rational, but root 24 is irrational. So, what we do? You divide this by another irrational number. Both of them are irrational and we will learn how to divide. See, this can be written as a common symbol 24 by 6. So, this is nothing but say root A by root B. This is nothing but root of A divided by B. This is what it means. So, it is the same as that. Now, we can solve this first, 24 by 6, which is what? Root of 4, and what is the answer for that? Plus or minus 2. Now, this is irrational, but our final answer is rational, but that is not always true. Okay. It does not mean that just because you are dividing one irrational number with another will surely give you a rational. No, you can also get both the answer as irrational also. For example, if I write 15, root of 15 and root of 3, root 15 that is irrational, root 3 is also irrational. So, I can write this as root of 15 by 3, what is that? Root 5, and that is irrational. So, see the difference between the two, both may be irrational, the final answer will be rational sometimes, or both can be irrational, the final answer may turn out to be irrational. So, these answers are very important for you to understand that the law does not say that every time you divide one irrational by another should only give you irrational, it can be rational or irrational. So, this is the just a very simple way of dividing. Okay. Before we proceed into other levels of division, we have to learn what is known as rationalization of the denominator. So, what is that? We will learn that. Okay, we already know when we did rational numbers and also irrational number on the number line, we know how to plot them, isn't it? So, we knew how to put 1 by 2 on the number line, it was very easy. We have already learned how to put root 2 or for that matter root 3 or say root 9.2, all these irrational numbers also on the number line. But what happens if I want to write something like this 1 by root 2 on the number line? You already know root 2 is actually equal to 1.414, of course it goes on. It is a non-terminating and non-recurring decimal, that is why it is called irrational number. So, if I have this number in the denominator, it is not easy to divide to start with. It is also not easy to plot this one on the number line. So, what we do whenever we have an irrational number in the denominator, we try to rationalize it, that is we somehow will make this number as rational. Rational means any whole number we can easily make it. How do I make root 2 as any rational number? Root 2 can be made a rational number 2 by multiplying by another root 2, isn't it? This becomes this when I multiply by root 2. So, if I multiply root 2 by root 2, I will get the answer as what? Root 2 into root 2 is root 4, which is again 2. So, root 2 has been rationalized by multiplying with another irrational number, and this is known as rationalization factor. Okay. So, this I can multiply by root 2, but I just cannot go about multiplying only the denominator. In order to keep the value of the fraction same, I have to do for the numerator also. So, what do I get? Root 2 by denominator, root 2 into root 2 is 2. Now, this is a number which can be plotted on the number line. So, this is the way any irrational number which has got, this itself is an irrational number, particularly with an irrational number in the denominator, this has been rationalized by multiplying by root 2 to get root 2 by 2, and this can be plotted on the number line. So, any such number has to be immediately converted into this form, that is all. Okay. So, there are some standard rules. For example, 1 by 3 root 2. Now, immediately what we will think, if I multiply both the numerator 3 root 2 and the denominator also by 3 root 2, I get 3 root 2 in the numerator. What is denominator? 3 into 3, 9, and then root 2 into root 2 is 2. So, 9 into 2, and I can proceed. This can be written as 3 root 2 by 9 2s are 18. Of course, I can cancel and get it 6. But why go through all these things? There is no need to multiply by another 3. I can directly write it like this. 3 root 2 can be multiplied by root 2 into root 2. What happens? The numerator is root 2. The denominators become 3. And this root 2 into root 2 is 2. So, 2 into 3, 6. Look at the answer. They are the same. So, for 3 root 2, the rationalization factor is not 3 root 2, but only root 2. So, whatever is inside this root symbol has to be taken as the rationalization factor and just multiplied with that, so that the denominator does not have any number under the root symbol. That is what it means. So, denominator is now only 6. That solves our problem. Okay, so like this we can do for anything. For example, 1 by 4 root 5. So, what do we multiply with? Only root 5, that is enough. So, if I multiply by root 5, here also I multiply by root 5, I will get root 5 in the denominator, in the numerator of course, and denominator 4 into root 5 into root 5. What is root 5 into root 5? Is 5. 5 into 4, 20. So, this is the answer for this question. So, we say that 1 by 4 root 5 has been rationalized. That is what it means. That is, you rationalize the denominator. The denominator was an irrational number. It has been made into a rational number. So, rationalization of the denominator is a very important thing for you to proceed in order to solve problems later on. So, there are some standard formulae for this which we will learn now. Okay, when we were doing multiplication, we learnt something like this, isn't it? Say 3 plus root 2, okay. Then I multiplied with 3 minus root 2, and we want to know how we multiplied, and we really used our algebraic identity. Say this is A and this is B. So, A plus B, and this is A minus B, and you know very well A plus B into A minus B is A square minus B square. So, using that, what do we get here? A square minus B square. What is A? 3. So, 3 square, and what is B? Root 2. So, A square minus B, this is root 2 square. So, this is nothing but this, using the same algebraic identity. And what do I get here? 9. And what is this? Root 2 and square. Once you finding root, the other time you are just doing the opposite of root, which is square. So, they just cancel out each other. The root and the square will cancel out each other, and you will get what is known as 2. What does it mean actually? Root 2 into root 2. Nothing special, which is 2. So, that is why I have written 2. What do you get? 7. So, 3 plus root 2 into 3 minus root 2 has actually given me 7, which is a rational number. So, even though these two are irrational, the multiplication of these two irrational number is actually a rational number. Now, this is a very important thing for us to use that in the rationalization. For example, the same thing. If this is what I have the fraction, the denominator is irrational. How do I make it rational? Just now we have seen, if I multiply this by this, the only difference here is it is plus here, here it is minus. If I multiply these two, I am going to get a rational number. Why don't I use the same trick here? So, I multiply both the numerator, what is the numerator? 3 minus root 2, this is what I multiply, and in the denominator also I multiply by 3 minus root 2. And I know very well, when I multiply this and this, what is the answer? 7. So, denominator I am 100% sure is going to be 7, which has already been rationalized. So, this number when multiplied by this has given me a rationalized denominator. Numerator I do not mind, let it remain irrational, does not make any difference. It is the denominator which makes all the difference. So, what I have done? So, a plus sign I have multiplied with the minus sign. This number and this number are known as conjugate of each other. So, 3 plus root 2, what is the conjugate? 3 minus root 2. Had it been 1 by say 4 minus root 3. Now, what will be the conjugate? I multiply by denominator 4 plus root 3. Its conjugate, can you see that? Minus has become plus. Here plus became minus. Does not make any difference. In any case, it is A minus B a plus b, it is going to be a square minus b square, that is 100% going to be a rational number. So, numerator of course same thing, 4 plus root 3. Be very careful, what you multiply here is the same as what is going to go to the numerator. Now, multiply the numerators, multiply the denominators. Numerator no problem, it is going to remain irrational, that is okay, it is not our headache. The denominator is what we want to know. So, a minus b, a plus b is a square minus b square, which is 4 square minus root 3 square. So, this is 4 plus root 3 in the numerator, denominator it is 16 minus 3. So, what do we get here? This is 4 plus root 3, the denominator being 16 minus 3 is 13. So, look at this fraction which we started with and see where it has gone. This fraction with an irrational denominator, the denominator is irrational, has been converted into another fraction of the same type, the same value, with the denominator being rational. So, this process of converting the denominator from irrational into rational is known as rationalization of the denominator. So, whenever we do problems, whenever you get any fraction like this, our first step is to make it equal to this. So, these two are same actually. Okay. So, this has to be first converted into this and then we will start doing the problem. So, this process is known as rationalization of the denominator, where the irrational number is converted into the rational number for the denominator.